Unit 1. Force and motion. Lesson 1. Motion in one direction. Motion. What's meant by motion? It is the change of object position as time passes according to the location of another object. This person will represent our observer for our reference, and this person will be the moving one. He will move from his position toward this person. As we can see, this one moved from point A to B. He covered a distance of 10 meters during 5 seconds. So this person is in motion. Motion is the change of object position as time passes according to the location of another object. Note the following. The path of a moving object may be: number 1, straight, like this motion. Number 2, curved, such this motion. Number 3, a combination of each. In other words, this object may move in a straight line, then in a curved line. The simplest type of motion is the motion in a straight line in one direction. For example, the motion of train or metro, because train or metro can only move forward or backward. Speed. What's meant by speed? It is the distance moved through a unit time. We will use the first example again. This person will represent the observer, the reference, and this one is the moving person. He will move toward the observer. As we said before, he changed his position from point A to B, and he took a time to cover this distance. So the mathematical relation that we can use to calculate the speed is speed equal distance over time. We can use this triangle to find the other two unknowns. If you want to find the time will equal to distance over speed. If you want to find the distance, it will be equal to speed times time. Note the following. The measuring unit of speed is meter per second or kilometer per hour. To convert between the two units, we use the following conversions. To convert from kilometer per hour into meter per second, we have to multiply by 1000 over 3600, or in the simplest form, 5 over 18. To convert from meter per second into kilometer per hour, we have to multiply by 3600 over 1000, or in the simplest form, 18 over 5. Example 1. A car is moving with a speed of 72 km per hour. Calculate its speed in meter per second. 72 km per hour, we will multiply it by 1000 over 3600. It would be equal 20 meter per second. Example 2. A train travels from Cairo to Alex, a distance of 250 km, in 2 hours. Find its speed in kilometer per hour and meter per second. First, we have to write down the given. Distance equal 250 km, time equals 2 hours, speed is unknown. the rule: speed equal distance over time equal 250 over 2 equals 125 km per hour. To answer the second part, we have to convert from kilometer per hour into meter per second. So we have to multiply this 125 times 1000 over 3600, and it will be equal approximately 34.7 meter per second. Types of speed. We have two types of speed: regular speed and irregular speed, or we can say uniform speed and non-uniform speed. The first point of comparison is the definition. What's meant by regular speed? It is the change of object position by equal distances at equal periods of time. As we can see, this car moved from point A to B, a distance 10 meters in 1 second. Then from B to C, also 10 meters in 1 second. Finally from C to D, 10 meters in 1 second. This means that this car is moving with uniform speed because it covers equal distances at equal periods of time. But what's meant by irregular speed? It is the change of object position by unequal distances at equal periods of time, or we can say it is the change of object position by equal distances at unequal periods of time. As we can see from this image, this car moved from A to B, a distance of 5 meters in 1 second. Then it covered a distance of 4 meters only from B to C in 1 second. Finally, it covered a distance of 11 meters from C to D in 1 second. So this car is moving with irregular speed because it covered unequal distances at equal periods of time. The second point of comparison is the rule that we use to calculate both of them. To calculate the regular speed, we use this rule: V equal delta D over delta T, which means that the change in distance with respect to time. And this rule is valid only for regular speed. But for irregular speed, we can't calculate it, but we can calculate the average speed instead of that. The average speed is equal to the total distance covered over the total time taken by this object to cover this distance. The third point of comparison is what is the relation between average speed and each type of these two types. Average speed is equal to regular speed, but average speed does not equal to irregular speed. Examples: the speed of light is the only example that we can give for regular or uniform speed. Examples for irregular speed, of course, the car which is moving with non-uniform speed. This is of course due to the traffic conditions. Average speed. What's meant by average speed? What's meant by average speed? It is the total distance covered by the moving object divided by the total time taken to cover this distance. For example, let's see this motion first. As we just saw, this person moved from A to B, a distance of 20 meters during 2 seconds. Then he moved from B to C, a distance of 60 meters, during 5 seconds. Then he moved from C to D and he covered the distance of 20 meters during 3 seconds. So to calculate his average speed, we will use this relation. Average speed is equal to the total distance over the total time. The total distance covered by this person equals to 20 plus 60 plus 20. And the total time taken to cover this distance equals 2 plus 5 plus 3. So the average speed in this case is equal to 10 meters per second. Relative speed. What's meant by relative speed? It is the speed of a moving object relative to an observer. We have 3 cases in which we can calculate the relative speed. Calculating the relative speed. Case 1. If the observer is at rest means it doesn't move. We have a car. This car is moving with a speed of 60 km per hour, and we have our observer which is at rest. The car is moving with the speed of 60 km per hour. This is its real speed. Our observer calculated its speed relative to him. He found that its relative speed also equals 60 km per hour. This is because our observer is at rest, which means that his speed is 0, and for an observer which is at rest, the relative speed is equal to the real speed of the moving object. Case 2. If the observer is moving in the same direction of the moving object. For example, we have our moving car which is moving with a real speed of 60 km per hour, and we have our observer, but in this case he is moving also with a speed of 20 km in the same direction of this car, as we can see. The relative speed in this case is the difference between their speeds. So if we have an observer which is moving in the same direction of the object, the relative speed is equal to the object speed minus observer's speed. The third and final case. If the observer is moving in the opposite direction of the moving object. Our car which is moving with a real speed of 60 km per hour. Our observer, but in this case he is moving with speed of 20 km but in the opposite direction of the car. As we can conclude, the relative speed in this case equal the sum of their speeds. The relative speed is equal to 60 plus 20 equal 80 kilometers per hour. So for an observer which is moving in the opposite direction of an object, the relative speed is equal to object speed plus observer's speed. Let's solve some problems. Problem 1. Calculate the speed of a runner Calculate the speed of a runner who runs 180 meters in 60 seconds. First, we have to write down the givens. Speed is unknown. Distance equal 180 meters. Time equal 60 seconds. This is the magic triangle that we will use, from which we can say speed equal distance over time equals 180 over 60 equals 3 meters per second. Problem 2. A car moves with a speed of 20 meters per second. Find the distance covered by the car in 60 seconds. We will write down the given first. Speed equal 20 meters per second. Distance is unknown. Time equals 60 seconds. We want to find distance, so from the magic triangle, distance equal velocity, distance equal speed times time equals 20 times 60 equal 1200 meters, or if we want to convert it into kilometer, it will be equal to 1.2 kilometers. Problem 3. A train covers 50 meters in 2 seconds. Find its speed in kilometers per hour. Distance equals 50 meters. Time equals 2 seconds. Speed is unknown. We want to find the speed. So from the magic triangle, speed equals distance over time equals 50 over 2 equals 25 meters per second. If we want to change it into kilometers per hour, we will multiply by 18 over 5 in the simplest form, and it will be equal to 90 kilometers per hour. Problem number 4. Calculate the distance covered by a car which moves at regular speed 100 kilometers per hour during number 1, a time of half an hour. Speed equal 100 kilometers per hour. Time equals half an hour. Distance is unknown. By using the magic triangle, we can find the distance, and distance equals speed times time equals 100 times half equal 50 kilometers. But if the time equals to 2 hours, so speed equal 100 kilometers per hour, time equal 2 hours, so the distance will be equal to speed times time equals 100 times 2 equal 200 kilometers. Problem number 5. Two cars move in the same direction. Car A moves at speed of 30 kilometers per hour and car B moves at speed 80 kilometers per hour, while car C moves in the opposite direction at speed of 40 kilometers per hour. Calculate the relative speed of car B relative to an observer. Number 1, stands on the ground. We have car B which moves with a speed of 80 kilometers per hour, and we have our observer. According to this point, he is at rest, so the relative speed in this case equals to the real speed of the object equals 80 kilometers per hour. But if the observer is in car A, he said that car A is moving with a speed of 30 kilometers per hour, and they are moving in the same direction, so the relative speed is equal to the difference between their speeds. As we can see from this motion, the relative speed equals 80 minus 30 equals 50 kilometers per hour. The final case, if the observer is in car C. Car C is moving with a speed of 40 kilometers per hour in the opposite direction of car B, so the relative speed equals the sum of their speeds. The relative speed equals 80 plus 40 equal 120 km per hour. Thanks for watching. This is lesson 1.